Hello, everyone. Hopefully, you got to do yesterday's homework and you finished everything up to page 28. So, today we're going to review a little bit more of some stoichiometry conversion factors. So, we are going to review stoichiometry. Keep getting that. Stoichiometry conversion factors. And so what we're going to look at is a little bit of mole to mole, which we were doing earlier yesterday, which was page 28, number 5. Okay, we're also going to look at a little bit of gram per mole, which is what we did yesterday right at the end of the video, and vice versa. So we could go from grams to moles, or we could go from moles to grams. And this was page 29, top number 3, which we'll take a look at. And then our last one, which is to try grams to grams. Okay, and these are calculations on the bottom of page 29. And page 29 on the bottom. Okay, so that's what we're going to do. There is attached today a stoichiometry worksheet. So homework today is to finish, that's a finish, up to page 29. And our worksheet, which you can find on the Google Classroom. Okay, and another thing to notice is that there will be a quiz coming on Monday. Okay, so just to get you ready for that, and I will be back on Monday. All right, so the 3 questions that we're going to look at, 3 questions that we are going to look at right now is mole to mole. So if I give you moles, can you find moles? Gram to mole or moles to grams? And then the last one, which is the most difficult that we have, is grams to grams. Okay, so let's start looking at some of those types of questions. So on page 28, on the bottom, number 5, bottom number 5. And if I break this open, I just want to look at what the question is, and I was not prepared. Of course not. So bottom page 28, number 5, how many moles, so moles of propane are required to produce 0.47 moles of carbon dioxide. Oop, that was a funky looking O. There we go, CO2. Okay, so again, moles of propane is what we are requiring. So we know that we have X moles, and propane we know because we look at our stoichiometric ratio. Actually, maybe I should have written that down there so that you have that available. Okay, so our balanced chemical equation comes right off of our sheet. It's just a little easier if it's written in front of you. So C3H8 gas plus 5 oxygen molecules or diatomics go to give us 3 carbon dioxides gas plus 4 H2O. Ooh, that's a bad looking O. And that'll be a gas. Okay, so again, for number 5, we want to find our X moles of propane, which is C3H8, and to produce 0.47 moles. So 0.47 moles of CO2, oops, that's a 47. That's not very good. There we go. 47 moles of CO2. Okay, and we need a conversion factor here, which we have moles of CO2 we want to divide by, and we need moles of propane on the top, C3H8. Okay, and if we look, our balanced chemical equation will do this, and if we look at our moles of CO2, we have a 3. And if we look at our moles of C3H8, we know that there is an understood 1 there. Okay, and calculating or picking up your calculator for this, we can do this. Oh, I should look at so we cancel out our moles of CO2 and we're left with moles of propane. Okay, I always forget to do that. Anyways, now we pick up our calculator, 0.47 multiplied by 1 divided by 3, and we get 0.156666, and I think that's repeating, and that would be moles of C3H8. But we have not looked at our significant figures yet. So we know that our significant figures in our balanced chemical equation is infinity. So those are infinity significant figures. Infinity significant figures. And here we have 2 significant figures. So our answer can only have 2 significant figures. And if we do that, we know that these 2 should be significant under here. So we have 2 significant figures here. So when we round, we have 0. The 6 moves up the 5. So we have 1/6 moles of C3H8. Okay? Okay, and why are these infinity for significant figures? Because they are counted. Let me just switch back here. So they are counted. Counted. So therefore they are infinity significant figures. Remember that from the first day we did significant figures last week. Okay, and so our stoichiometric ratio. So our stoichiometric ratio is always infinity significant figures. Okay? Okay, now we were going to do 2 more. So our next one, we're going to do grams per mole. And this one is page 29 on the top, number 3. So let's get that reorganized. So page 29, top, number 3. Okay, and some mole mass problems. So our balanced chemical equation we have is C12H26, which is a liquid. At that point, they get too big to be gases anymore. We have 37 oxygens as a gas, and we react those together. It is combustion, so we get 12 CO2 gas, and we get 13 water vapor. Okay, and then question number 3 asks us, how many moles of oxygen are required to produce 560 grams of water? So we're looking for moles of O2 to produce 560 grams of water. Okay, now if you like to do this, so again, we're linking oxygen to our water, and we have 560 grams of water, and we have X moles of oxygen. Okay, and yeah, did we do that again? That was 3702, wasn't it? All right, let's, yeah, this is the one that has a correction in it. It's actually 37 divided by 2. Okay, because our handouts are not balanced correctly. Sorry about that. Okay, so what we want to do is we want to have our setup is X moles of O2. All right, but the only thing that we know is 560 grams of water. So we know that we can use our molecular mass for water, and if we go off to the side, we can figure out our molecular mass of water. I'll just kind of drag it over here a little bit. So we have 2 times hydrogen, which is 2.0, I think it's 17, something like that. And we have 1 times an oxygen, which is 15.997. And if we add those up, we are going to get 18.01528. Now, obviously, I did not use enough decimal places on there, but if you use the decimal places from your periodic table, that works. Okay, so now we need to figure out what we can do for grams of water, and we want to find moles of water, because moles to moles is the only thing we really know how to do with our stoichiometric conversion factors. Whew, that was a good one. Okay, and we have 18.01528 grams in 1 mole of water. Okay, looking at our units, we've now gotten rid of grams of H2O. We're in moles of H2O. But moles of H2O is not what we want. We want moles of oxygen. So we know that we need to divide by moles of oxygen. And we need to find our moles. Wait a minute. We need to divide by our, oh, sorry, guys. We need to divide by our moles of H2O. And we need to have moles of oxygen on the top. That makes much better sense. Okay, where do we find this? This is our stoichiometric ratio. And moles of H2O is right out of our balanced chemical equation, in which case we have 13. And our moles of O2 happen to be 37 divided by 2. And we can put that in as a fraction if you want in your calculator, or just calculate it out separately. And when we pick up, we're going to check out our units now. So moles, we have moles of H2 being divided, or moles of water being divided, moles of water being divided, and we're left with moles of oxygen, which is our goal. Okay, picking up our calculator, we take 560 multiplied by 1 divided by 18.01528 multiplied by 32 divided by 2, and then divide it again by 13. When you do this, you get 44.2359 5286. Had to look up on my calculator again. Now, we're going to take a look at, again, significant figures. Here we have 7 significant figures. Remember, here we have infinite number of significant figures. This is infinite number of significant figures. And by definition, this is an infinite number of significant figures. On our initial, what we were given, we weren't given a decimal place there, so this is actually 2 significant figures. Okay, so we want to only have 2 significant figures here, so we're going to drop a line right here, and we're going to look at that 2 afterwards. It is not greater than or equal to 5, so we are going to have just 44 moles of O2. Okay, now our last one, which is the hardest type that we are going to learn how to do this year, is page 29 on the bottom. We're going to look at number 1. And in this one, we have a new chemical equation, balanced chemical equation, and we have propane, gas, plus 5 oxygen molecules, gas, give us, again, CO2, gas, plus, I forgot the number in there, but that's okay. We'll write it in, H2O, gas, or vapor. Okay, and we needed 3 of those and 4 hydrogens. There we go. Okay, now our question happens to be calculate the mass of propane. So mass of C3H8, that's an 8, required to produce 3.8 kilograms of carbon dioxide. Okay, and if you like to use your arrows, here we go. So this right here is going to be our X grams. And over here, we have 3.8 kilograms. But, okay, we'll just leave it like that. Okay, so 3.8 kilograms, and we're going backwards in this case. We're going to look for the reactant. How much reactant do we need to put in order to produce that? Okay, so we're going to start out with our X grams, what we're looking for, of propane. And the only other thing that the question gave us was 3.8 kilograms of CO2. Okay, that's going to cause us a little bit of a problem, isn't it? Because we only deal in grams when we talk about our molecular masses. So what we need to do is just convert this. And we know that we need to divide by kilograms, and we need grams on the top. And you guys should be very familiar with this by now, that 1 kilogram is equal to 1,000 grams. Okay, now that we're left with grams, we should put CO2 in there, CO2, so they actually come off. Okay, and we have now gotten rid of grams or kilograms of CO2, and we're left with grams of CO2. Okay, if we have grams of CO2, we know we can divide by those in order to figure out moles of CO2. And for using that, we use the molecular mass of CO2, which is 44.0098. We've already looked that up and calculated it in this set of problems, and that gives us 1 mole of CO2. Checking our units, right here. We've now divided by grams of CO2, and we're left with moles of CO2. So if we want to divide by moles of CO2, and we want moles of C3H8, we use our stoichiometric ratios. We have 3 moles of carbon dioxide for, remember, that's a 1. So we have a 3-to-1 ratio, or a 1-to-3 ratio, depending on looking up or looking down. Okay, looking at our units now, we now have moles of propane. How do we find our grams of propane? Well, we need to have moles of propane on the bottom, C3H8, and we know that 1 mole of C3H8 is equal to 44.09, oops, that's a decimal, 09652. And that is grams of propane. Okay, looking at our units again, we've now gotten rid of these moles of propane, and we're left with grams of propane. That makes us all happy because that is what we are looking for. Okay, so picking up our calculator, we are going to take a look at what we get. So we are going to take 3.8. We are going to multiply by 1,000, divide by 1. Do we really need to divide by 1? And if you're telling me no, then you are correct. We really don't need to divide by that 1. Okay, but then we will multiply by 1, divide by 44.0098, multiply by 1, divide by 3, multiply by 44, and do we need to divide by that last one? Not really. Okay, so when you've calculated that all into your calculator, please check your answer here. You should have typed that all in already. 162,596. And that is grams of propane. Okay, now we are going to look at our significant figures. Remember that when we look at significant figures, we know that each of our conversion factors, this is infinite numbers of significant figures. I just forgot the word infinite. There we go, infinite numbers of significant figures. And this one is also infinite number of significant figures because it's a conversion factor. This is our only one that has 2 significant figures. Okay, in this case, we know that we need to do our significant figures at there because we'd only have 2 left. We look at the number behind it, and it is a 6. So we know that, forgot to change colors. There we go. We know that that 6 would bump up the 2, and we would have 1,300 grams of C3H8. Now, if significant figures are easier for you, you could put this into significant figure or scientific notation, which is 1,269,162,596 times 10 to the 3. Okay, in which case, when we do our rounding to 2 significant figures, it makes a little bit more sense. Like I said last week, that scientific notation is sometimes your friend when you're trying to figure out significant figures. Okay? And grams of C3H8. Okay, so that is everything that I have for you today. Please, again, if you're having any really big problems, email me. I will try to get you a little video set up and tacked onto the Google Classroom as soon as I can. Okay, everyone have a great day, and check in with you tomorrow. Bye now.